All right, day 3. Here we go. Always a little bit of a chug to load at the beginning. It's funny. Okay, there's my puzzle input. And let's paste that. I don't know why, for some reason, it thinks that util is not valid. Something to do with my linter. Okay. Open squares and trees. Exact integer coordinates, great. The open square of the top left corner. Need to reach the bottom, below the bottommost row of your map. Okay. Oh, is this going to be A star? This might be A star type thing. Counting all the trees you would encounter for the slope right 3, down 1. Okay. Until past the bottom of the map. Right 3, down 1. How many trees would you encounter? Okay, so this seems like a vector type of thing. So our movement vector, so we're just going to say our location is equal to 0, 0. And we're going to sum some vectors is what's going to happen. Do we want this to just be a list? I think so. Let's just print L real quick and see what it looks like. Excellent. So we've got this nice list of things, and we're going to have to do some modular arithmetic, and we're going to have our V is equal to, and it says here, so it's, so we've got X, Y is the top left. So X is on the so it's actually 1, right 3 and down 1. So right 3 is x of 3 and down 1 is that of 1. Great. Now we need to see how many trees we encounter. So we're going to say for row in L, and we're going to first update our location. So loc is equal to util dot vec add of loc and v, and then we're going to say, now we need to figure out exactly what is in this place. So let's look at that for a second. Okay, cool. Wow, that's long. Okay. So we need to figure out where we are in this guy. So if it repeats infinitely, we just take it modulo the length of it, I think. So we're just going to take our x value and we're going to say, so let's just say that I is equal to our x value, and we're going to take it, I think that's modulo in Python. Let me double check though. Python modulo. Yeah, I think it's just the percent operator. Excellent. Okay, and that's just going to be modulo the length of the row. And then we're going to say that, oh, we also need to keep track of the number of trees. Trees equal to 0. And we're going to say if row of I is equal to, and it's a hash for a tree, then trees equal to trees plus 1. And then we don't want to print L at the end, we want to print trees. Save please, and run. Invalid syntax. Ah, forgot to double equals. 71. Not the right answer, dang it, okay. So usually what I do here is I do this example and see what happens. Oh, you know what might be wrong? I think that I need to do this at the end. I think it might be off by 1. Because in the first row, I want to be looking at the 0, 0 location. And no, that should be fine. No, because I'm adding to it before. Okay, yeah, I think I'm adding 1 too many times. So let's try this again. Boom, it's 247. That looks like a much more reasonable answer. 12 seconds left to wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 for good luck, 14 for better luck. Yeah, okay. 960. Wow, okay. Okay. Each of those, well, this is really easy because now we just do this for each of these vectors. So we can just move this into a function. We're just going to say function def trees on slope. Oh, I should use snake case because I'm writing Python. Slope, and we're going to say we want the L that you're using and the vector that you're using, and then we're going to do this. Bloop. Let's tab all that in. Return trees. And let's get lock is equal to. Okay, trees is 0, 4, and so let's first just try print trees on slope, and it's going to be L and 3, 1. Let's try running that. 247, that's exactly what we wanted, and we can get rid of all of that. And so now we need to multiply together all of these guys. Great. So let's just get these converted into the right. So that's 1, 1, 3, 1, 5, 1. Seven, 1. We're going to have to modify our function slightly. 1, 2. Yeah, because now we're no longer doing for row and L. Okay, so now we're going to just have a different condition and say, we're going to have a while loop. We're going to say while lock, essentially it's while the, oops, I locked something on my keyboard. There we go, fixed it. While location of, we want to know if the y value, so of 1, is less than or equal to, well, less than the length of L. And we're going to say, and then we're going to say lock is equal to the vec add of those two things. I think this will still work. So let's just comment that out and try running it. Row is not defined. So now it's the lock value, right? So we're going to have lock of 0, because the, or no, lock of 1, because it's a y. sorry, we want L of lock of 1. And L of lock. Wait, let me undo this. Something bad happened. That's getting the character. Okay. Length of the row. So the row is L of lock of 1. Great. And then this thing is the row, so we need to fix this. So this is supposed to be... So let's get L of lock of 1. Lock of 1. And then we want the ith character in that. Why am I getting some red squigglies? Oh, well, it worked, so. Cool, finished A3. Well, let's see if I did a little bit better on the second half. Oh wait, I want my personal stats. Nope, not better. Oh well. Definitely not my quickest day, but I'm pretty satisfied with this answer, like, just straight off the bat. Like, I don't think I have much cleaning up to do. Like, the one thing that I probably could do is, like, put these in a list and like, kind of feed that into some sort of an iterator that joins them together for this, because this is a little bit messy. But other than that, like, it seems like things went pretty smoothly, because I'm happy with, like, the vector addition and stuff that we did. Yeah. Yeah, so let's write something little so this is like we can give it a list of vectors and it just iterates through all of those and multiplies them together. That sounds like a cool thing to do. My guess is that's just done with reduce. I haven't written a reduce function in a while because I haven't done much functional programming, but let's just try it. Let's see what happens. So first of all, let's do print part 1 solution. I'm going to print part 2 solution, and then we're going to say vec array is equal to, oops, we have 1, 1, 3, 1, 5, 1, 7, 1, 1, oops, 1, 2, excellent. And now we're going to write this little reduce function. And we need to start off with 1 because we're multiplying. So we're going to write reduce. I'm going to quickly Google Python reduce syntax. Now I can do it with a lambda. Wait a minute, this is saying that I need to import functools? That isn't just built in? Yeah, I guess you have to run that, which I might have to pip install or something. But it's already... Let's just try, if we can just try it and it works, then why need this and then 100? And this should just print out 100. Reduce is not defined. Great. Bam. Okay, cool. So that's it. So what we actually want to do is we want to say lambda of x comma y and return x times y, and then we want to hand in the trees, or no, not trees on slope, sorry. oh, we don't even want to turn in x times y. So let's hear. So the accumulator is x. So we want x times, and then the y value is going to be the new input. So we actually want trees on slope of, then we want L comma Y, and then our initial value is going to be 1, because 1 is the base for multiplication, so that it doesn't zero it out. It would be 0 if it was addition, and then we're going to say that the list is vec array. This is kind of just an exercise. It's definitely, like, given that we're only a couple of these, it was so much easier to just do that, but I think this is good to do. And that looks like the same answer. Cool, cool. Well, I'm glad that I know that now from functools import reduce. Huh. Cool. Well, I'm also seeing that I forgot to push up my changes from yesterday, so I think that I'm gonna clean this up and get it pushed up. But anyway, thanks for watching.